Hi, Ashton Posey, back with another pterodactyl video. We made some adjustments to the pterodactyl, and so we are making a new video to add some more information to the last one. So first off, we have 3 GPSs that this pterodactyl was originally made for. These have this off-board antenna that's pretty large and can be put basically anywhere inside of a box. But recently we just found out that this antenna on the GPS that was sent out in all the NEBP kits has a lot of interference when it's placed on its regular spot on the board from these IO pins, because that's how the GPS is able to sit on the PCB. And also from recent flights, we figured out that the GPS does not perform well when it's at the bottom of a payload. And so to solve both of these issues, we just decided to do an I2C connection with the GPS, and this allows it to be taken off the board and placed anywhere on your payload to make sure it can get a secure connection. Right. And I just wanted to make a new note about the old video I made. I said that the GPS was locked whenever the satellites in view was displaying greater than 0, which is actually incorrect for the code that I was showing. I was showing this old GPS code, and with this code, you actually have to make sure that the altitude is locked before knowing that the GPS is locked. And then with the new high precision code, which is loaded in this version 15, you have to make sure that the satellites in view is greater than 0 to make sure that it's locked. All right. And then finally, there's a new setup procedure with the pterodactyl board. And I'm going to show that off right now. So first off, it asks if you want a new configuration. I'm going to select yes. And what this configuration means is that the configuration that you originally put on your board, so let's say you started up and input all the correct information, all of that information will be stored on this SD card. And if there isn't a current configuration stored in the SD card and you select no, not a new configuration, it will still ask you to enter a new configuration. But with all the information being stored on the SD card, it allows you to select no, not a new configuration, and then it will read all that information from the SD card and set up the pterodactyl accordingly. And this allows, I guess, you don't have to input so many things in every time you turn on the pterodactyl, but also if it turns off mid-flight, it allows the pterodactyl to basically boot itself back up with all the information that allowed it to fly in the first place. And next we have heater, and we won't be using a heater since this is just a single board. This just allowed the heater code to be taken off as a separate code and just put into the main pterodactyl code. So I'm going to select off. And then using MS5611, I'm going to select yes. And then IMU type, we have a BNO because it's the black one, not the red one. And then high precision GPS. This is a new modification that I added just so that both of the, or no, this will allow the GPS to be used even if it's not configured for high precision. You just have to select not using the high precision version of the code. And I'm just going to select no for ease of use. Or actually, I'm going to restart that just so that I can select yes on high precision and show everything off using a new configuration. Yes. MS heater. Nope. MS5611. Yes. IMU type, BNO. High precision GPS, yes. And now it asks for I2C GPS, and this will be used whenever you have your GPS plugged in via I2C. And this will allow, like I said before, the GPS to be placed off the board. I just have it hooked up with this screw so that it can hold itself up, but usually it will be placed either at the top of your payload or close to the top at least. So I'm going to select yes, I squared C. And if your GPS is plugged into any of these headers, it's not I squared C. And that runs off of serial. And now I'm going to select the XBs in a mode where they won't communicate with anything or attempt to communicate with anything, which is as a relay with 0 XBs. All right. So now we have a new window that will be, I guess, a new series of screens that are available on the OLED. And with the switch off, it will just cycle through every screen. Every 5 seconds, it will change to a new screen. And the button will allow you to auto change the screens every time it's pressed. But with the switch on, it'll keep the same screen all the time. So right now we have lat long altitude with thermistor and pressure information and the satellites in view, and then the hertz that it's currently running at, which is 5 hertz. Now I'm going to move to the next screen with the button, ECEF coordinates of the device, and then the same stuff below it. And now it has UTM coordinates with the same stuff below it. And now we have the yaw, pitch, and roll of the device as defined by the IMU. And now we have the current file that data is being stored to, the current file that XB data that's being received is being stored to. Then we have channel and node identifier, and then XB ID, and then the current XB counter. And then below that, we have heater information. So this is at 999 and NA because the heater currently doesn't have a value and the status is not applicable. I'm going to push the button again. And now we have a timer since the device was turned on, and then a flight timer, which activates after a change in altitude of 100 feet is read. And if this second timer is ever going and your flight has not started yet, you'll probably want to restart your pterodactyl. And then we have the current time as given by the GPS, a date from the GPS, and then we have MS5611, altitude, and temperature information. And now we're back to lat long altitude, the original screen. And that's all the changes that have been made to the pterodactyl in the newest version of the code. Thank you.